previously I have to like go and manually like create a playbook YAML file, mention what are the atomics that I need. Like I have to manually go and search like the threat intel report. I have to go and find what are the TTPs it uses, and I have to go and check what are the TTPs are there in the Atomic Red Team repository, and I have to like manually go and search each and every one of these things. Right now, I just provide Claude a threat intel report, and it's going to like search for all the atomics and then create a playbook YAML file for me. And I can just like validate that playbook YAML file whether everything in the report is there. I don't have to like do a lot of other things apart from like just doing validation.
Thanks for joining us, everybody. Really excited for the 61st edition of our SecOps Weekly. And I'm really excited to be joined by Hare Sudan, who is one of our primary contributors, most longstanding contributors to Atomic Red Team. And we've got some really fun things that he's been working on that are now available to everyone in the public. And that all said, we'll go ahead and get kicked off. My name is Phil Hagen. I'm a researcher here with Zscaler, formerly Red Canary, and now really pumped to be able to work with not just the Atomic Red Team project, but our entire community team at Zscaler. And a big part of that is people who are outside the company, which is why we're excited to have Hare come in and contribute as well as to share those contributions with you all. Today, we're going to be talking about supercharging your Atomic Red Team usage, specifically with AI. There's a kind of like we were talking about at the beginning here. There's a couple of different ways you can do that. We're going to be focusing on one, which is specifically looking at the Model Context Protocol, or MCP server that Hare has developed. But there's also a lot of other neat things coming down the line. So stay tuned, and we'll talk about some ways of doing that toward the end of the session. But without any further delay, I'm going to turn it back to you, Hare, to kind of give us an overview of what you've put together and kind of what the use case is, because this can really streamline a lot of cool things for people who are either familiar with Atomic Red Team or are maybe just getting started. So let us know what you got put together here.
Yeah, thanks, Phil. Thanks for the intro, and thanks for having me here. So, hey everyone, we'll just like discuss about the Atomic Red Team MCP. So before going into the Atomic Red Team MCP, let's discuss what an MCP server is. Like MCP server is kind of like a pen drive or hard disk that you can like add to your Claude or Codex or like whatever you use. Similar to like how you use pen drives or like other storage devices for your computer to like expand your storage. Like these ones are going to give you additional tools and like other stuff that you can use with Claude or Codex to like help uh, search for something or like execute an atomic or like do things with the MCP. So there are also like skills which you can use, like agent skills which you can use. But what MCP provides is skills are like README documents or like Markdown documents that you can use to use the same thing as a CLI. But what MCP provides is like, let's say you are in an enterprise environment, you can just expose your MCP server and you can connect to it, like different people can connect to it and then use it. So MCP is going to like help you with those things. So with MCP, you also have like multiple tools, and you also have resources and prompts. So the first thing, tools are like functions, consider it as like Python functions that are exposed through an API that your Claude or Codex can call. And resources, you can, if you want to like directly get the data, you use resources to get it. So it's just like the data that's in the back of the DB, or in this case, it's going to be like the atomic YAML files. So you can query the YAML files directly, or you can query it through an API via the MCP tools. And there are like prompts which are like reusable workflow templates. For example, let's say if you want to like create an atomic, you can use one of the prompts that we have in the MCP to create it. It's just going to like give the entire like things to look for while you are creating an atomic. For example, the atomic needs name, description, executor, whatever the commands, prereqs. Like the prompts are going to like ask Claude or Codex to provide some guidelines for Claude or Codex to how to create an atomic. So, and you also have like multiple different transports. One is standard input and output, and the other one is like streamable HTTP. So you can either like host it as a HTTP server, for everyone in your enterprise environment to like connect to it. Or if you just want to like use it locally, you can just use the transport standard input output, the stdio, so that it's just on your local machine and no one else would be able to like access it if you just want to like keep it local.
Yeah, and that's one of the
And
things
you
that
can
I like.
also hook it up. Oh, sorry, go ahead.
Oh, I was just going to say, I always liked the flexibility with the way that you described it, and that you got all these larger models, which certainly come with potential security implications, but the ability to hot swap out almost those the tool that's used against all the backends means you can run the local ones as well.
Mhm. And one of the good thing about using like MCP servers is like you can plug and play different MCP servers. So previously, let's say you had like a SOAR platform or a SIEM platform, you will add additional integration so that you have like all the data in a single pane of glass. So MCP is going to do the same purpose as that. Like you can add your GitHub MCP server, Jira MCP server, you can add all of those things. And you can also like add Atomic Red Team MCP server. So let's say you have a Jira ticket to like run an adversary emulation campaign for APT41. You can just ask the MCP server to query your Jira MCP and see what are the ticket details. And you can ask it to create, like search for atomics that's there in the Atomic Red Team MCP server. And you can also ask it to like create a pull request using the GitHub MCP server. So you can plug and play things and you can mix and match stuff with it. You can also add your like detections MCP server, like Splunk or Elastic, MDE MCP server, like whatever it is, and it just like provides a easier interface to like work with. You just like use natural language to like query everything. You don't have to like uh, I feel the context switching was a lot before like AI and like MCP stuff came together. Like people were building custom tools and other things to like avoid context switching, but once they provided like a standard MCP interface, it was much easier for like people to work with all of these things.
Yeah, I think my brain, one of the ways that I got to really start understanding what MCP provides here is that
Mhm.
in any kind of an environment where you have an API, it's this very specific, very strict, rigid set of rules of you make this request, you provide this information, you get this response, it provides this information, which is super vital, and it really opened up a lot of opportunities to make platforms and ecosystems. And I've seen MCP as like that same glue between the front ends and the back ends, but it allows a more a looser kind of a definition of how that works. So instead of a rigid API, it's kind of this fuzzy API that allows you to interact with it through natural language, like you described. So if you're not anybody out in the attendees are not familiar with that, think of it as like this API that you can talk to, and that's the goal that it's sort of providing here. So really exciting to be able to do that. Give us an idea real quick of like some of the architecture involved and the different components and what their role is in the whole system.
Yeah, sure, Phil. Sorry, my internet is
Uh,
a little laggy.
no worries.
Yeah, so with MCP, you have a lot of things, like there are like a lot of other terms or like things that we need to like know about. So the first one is like MCP host, like that would be your machine where you have your like Claude or Codex or like whatever the tool that Cursor, VS Code, like whatever the thing that you are using, it's there. And you also have a MCP client. Oh, sorry, the MCP host is a machine that's running Claude or Codex or other things. You have the MCP client, which would be exactly the Claude or Codex. And you have like MCP server. It can be a local MCP server, as I mentioned before, like standard input output, or it can be a remote one. So you can host a HTTP server somewhere else on the network and you can like access it. Or it can also be like hosted on the cloud and you can like access it. So to summarize, host is going to be like your computer, client is going to be the tool that you're using, Cloud Codex, Cursor, whatever it is, and MCP server is the one that you are running on a cloud environment or like a common shared place, like in your environment, or you can also like run it locally depending upon your use case. So as we talked before, like MCP provides like a standard interface to like have everything in a single pane of glass. So traditionally, like before all the AI stuff came, like I've been working on Atomic Red Team since 2020, I believe. So previously, what I used to do was like whenever I started contributing to Atomic Red Team, I'll just manually go to the website, search whether a particular atomic exists, and if I want to run something, I will like manually copy the YAML from missions to mission. Like since I cannot like run everything on my Mac OS machine or my Linux machine, if I want to like run a Windows Atomic, I have to like manually copy the YAML that I created to the Windows machine, craft the input arguments, use invoke Atomic Red Team to run it, debug. Like let's say if it throws an error or something, I have to debug everything. Copy the error message from the machine and search it in Google, try to find out what's the issue, and then I have to like go and like find out and fix the YAML file. But once the MCPs and like AI stuff came in, all I had to do was like just ask the MCP to like go and create an atomic, search for like give a threat intel report or give it a document or a website that it can like point to and like go and read the document, and then ask it to like create the atomic, execute the atomic, and debug if everything is necessary. So you don't have to like context switch a lot. You have like everything in a single pane of glass, and you can also ask it like once it generates the YAML, if I want to like change something, I can just like ask it to like do the same thing in the natural language, and it's going to like make all of those changes. It's the same thing for like doing a campaign like adversary emulation campaign or something using Atomic Red Team as well. Previously, I have to like go and manually like create a playbook YAML file, mention what are the atomics that I need. Like I have to manually go and search like the threat intel report. I have to go and find what are the TTPs it uses, and I have to go and check what are the TTPs are there in the Atomic Red Team repository, and I have to like manually go and search each and every one of these things. Right now, I just provide Claude a threat intel report, and it's going to like search for all the atomics and then create a playbook YAML file for me, and I can just like validate that playbook YAML file whether everything in the report is there. I don't have to like do a lot of other things apart from like just doing validation on like what are the things like whether to verify whether Claude has generated the right things. So yeah, Phil, can you describe like how your workflow has changed after using Atomic Red Team MCP?
Oh, I was just saying that like 40 minutes of savings here is fantastic, and you start multiplying that by the number of times that you're going to run this.
Mhm.
And we've got a couple of demos coming up, or demo use cases coming up, where we'll kind of talk through that. But any time savings is good, and of course that allows us to do more work and optimize the workflow so that we're able to just accomplish more things, which is fantastic. And this is, we're going to talk just a little bit about this. If you can kind of get into a bit on what some of the components are,
Mhm.
and then I believe it's the next slide where we're going to start getting into the demo as well.
Yeah, yeah. So, yeah, like MCP server, as I mentioned before, it provides like a lot of tools and resources that you can use. So some of the core tools that we have in the MCP server or querying atomics, like we have around 1,500 plus atomics. I think it's 1,679 or something right now. So we have a lot of atomics right now in Atomic Red Team repository, and each one represents a TTP from a known threat actor. Like we follow the MITRE attack thing. So most of the uh, TTPs from MITRE attack are like covered by Atomic Red Team, and we have like a huge knowledge base of like TTPs over there, and you can query all of these atomics and you can find whichever one that suits you, and then you can run it. So execute atomic is another tool that we can use to like run the test directly on the machine. So previously what I used to do was like SSH into Linux machine, or like WinRM or RDP into the Windows machine, and then like run things. Right now what I do is like I just install Atomic Red Team MCP, like the HTTP Atomic Red Team MCP server on Windows, Linux, and Mac OS machines, and I just add those three MCP servers to my like Claude, and I just ask it to like query atomics and then run it. I don't have to like even like SSH into other machines or like WinRM into other machines anymore. So you have to like enable, it's a opt-in thing, so you have to like add a env variable to it so that like whenever by default it's turned off, because I don't want people to like try whenever they're trying out Atomic Red Team MCP. I don't want them to like expose their HTTP ports outside so that like someone can like run some certain things over that. So I just like turned it off, and you have to like add a env variable to turn it on. Yeah, the next one is like validate atomic. This one is like useful whenever you are trying to like create a new atomic. Like Claude is going to like help you create a new atomic, but sometimes the format might be wrong. Sometimes there might be other issues over there. So Claude is going to like help you validate whether the YAML format is right. It's also going to look for a couple other things based on the prompts that we provide. So there are certain things in the validate atomic prompt that it's going to like check for before like giving the final output to you. So let's say if it fails, if the YAML format is not right, or if there are like some things that's missing over there, Claude is going to like reiterate and like make changes to it, and then continuously call validate atomic until it gets a success message from there. So you don't have to like worry about fixing your YAML format or like other things, and it's going to like give you the final output easily. And one other thing that I had was like whenever I was deploying these Atomic Red Team MCP servers throughout my home lab and other places, there would be like frequent new atomic additions and other stuff. So I wanted an option to like download the latest atomics from the repository. So there is also an option for you to do that. The refresh atomics tool is going to help you with just that. So it's going to like download and pull the latest atomics from the repository, and then it's going to help you with some of that. And getting validation schema, like as users, we wouldn't like need it, but whenever like Claude is trying to like generate atomic YAML, so it needs to understand like how an atomic YAML should look like and what are each of those things, what are each of the fields in an atomic YAML. For example, elevation required, we can understand it, but a Claude or like Codex, it needs like some description with it. So the YAML schema is going to like provide that, like when to use the elevation required field, when not to use the elevation required field, when do you need dependency executor name field, some of those things. So the validation schema is going to provide the YAML schema and also like description for each and every one of those fields, like what are the values that supported. For example, we only support bash, sh, PowerShell, and manual executor. So whenever Claude generates, sometimes it might try to like use the executor as OSA script or like something else. So we want Claude or Codex, the MCP client, to know what are the fields that supported, what are the possible values that it can accept, things like that. So the get validation schema is going to like help your MCP client with that. And I also added a health check over there, which is the server info tool or server info endpoint, which is going to like get you like what are the server platform is, like what is the server status. So what happens whenever you like when you use like a single Atomic Red Team MCP server, I didn't have any issues with it. But whenever I use like multiple Atomic Red Team MCP servers, like one in Windows, one in Linux, one in Mac OS, we would like to know, like the Claude would like to know that which server has like which platform, because you can name your MCP whatever you want. So uh, if Claude wants to like run a particular Linux atomic, it needs to know like which MCP server supports that atomic. So the servers info tool is going to help Claude with that. So let's say you have three MCP servers connected to your MCP client, and you ask it to run a Linux atomic. What Claude is going to do is it's going to like query server info tool on all the three MCP servers, and it's going to like get you which of the servers that you can run that particular atomic in, and it's going to like provide you an option to choose one of those three servers to run it in. Let's say if all three are Linux. So
Yeah,
and
and
oh, sorry, go
I
ahead,
was
go
going
ahead.
to say my big takeaway on the tool side is it's a combination of user facing and internal capabilities that both
Mhm.
provide those capabilities to the user, but also are used internally for these kind of guardrails, making sure that the results are consistent and coherent and delivering something that in the end the goal here is it's more natively usable and actionable by that user. So the internal refinement is super helpful there as well.
Yeah, and with MCP, like with all of those tools, you also get a description. Like Claude would get a description of when to call these tools, when not to call these tools, what are the purpose of like each and every tool. So all of those things gets loaded on start. Like whenever you start MCP server with any of your MCP clients, like all of these tool names and descriptions get pulled into the context by default. So like the user doesn't have to do most of those things, and Claude can help you with some of those things. So, and finally, the resources, as I mentioned before, it exposes kind of like how a database exposes its like data. MCP with MCP, you can also expose data through resources. So here we expose our YAML files. Let's say if someone wants to like directly read the YAML file or like look at the YAML file and want to make some changes to it, they can also like query our YAML files through resources.
Yeah,
And we support like all the MCP clients, not only the things that's listed here, but any client that supports MCP, you can use it with Atomic Red Team MCP server.
perfect. Gives you maximum flexibility, especially for organizations where, you're limited to this one solution that's approved for use. So that way everybody can not run afoul of those guidelines. Super straightforward to install. And I think like if you can just kind of give us an idea of what the very briefly what some of the use cases are. I want to get into the demo to make sure we have enough time to kind of show this in practice as well, but installing it's really straightforward, just a couple of minutes. You can kind of see here, but can you touch on just like one or two of these to give an idea of how simple it is to get going from the beginning?
Yeah, sure. So as you can see here, it's like very easy to install. And as I mentioned before, if you want to add execution capabilities, you need to pass in this environment variable with it. Oh, I think I'm using the wrong color. Yeah, you need to pass in this environment variable with it, and you can use UV to run it. Like UV is a Python manager, like Python package management solution. You can also use pip if you prefer pip or pipex or whatever it is. I prefer UV because it manages like all my Python environments, and it automatically creates a virtual environment for each and every Python thing that I use. So I prefer UV. So I just mentioned the docs as UV, but in case UV is not approved in your organization or something like that, you can use pip3 install Atomic Red Team MCP, and you can just exclude UVX, and you just do Claude MCP add Atomic Red Team. This is the name of the MCP server that you want to call. You can replace Atomic Red Team with something else as well. So you can do like Claude MCP add the MCP name, and this is the package, Python package's name. So if you are using pip3, do pip3 install atomic dash red team dash MCP, and then you can just exclude UVX. So that should work. And we also provide a Docker container. If you don't want to like execute stuff on your machine, you can also use our Docker container, and you can pull those things from uh, you can use all of the tools that we have mentioned before using the Docker container as well. But note that whenever you're using Docker container and you are trying to execute atomics, it's going to execute it within the container and not on your machine. So just be something that you should be aware of. And if you want to like use it in like Claude desktop, you have to like go to slash library application support slash Claude and Claude desktop config.json, I think. So you have to go there and add this block. You have to go there and add this block to your MC like config.json file so that it's available on your Claude desktop as well, depending upon whether you use the CLI or desktop.
Yeah, lots of options. And then the only warning that I want to do, I know it's on the slide, but just to make sure that it's not overlooked, execution is running things. So as we know, autonomous running of tests that could be considered malicious can potentially get you into trouble. So rather than allowing that by default, the environment variables needed, as you mentioned, but really
Mhm.
make sure that that's only done in an
Got
environment such as a lab where it's appropriate to do that. And we'll hit that warning a little bit later on. The demo that we've got lined up for you is this one right here. And I always like to say it's more fun to see than to talk through. Basically, this is one where, let's say you get a new threat intelligence report in, and you're like, oh, I'd really like to turn this into a set of tests. You're moving toward adversary emulation. Normally, that can take a long time. It's a cognitive load, and it's going to require validation and troubleshooting. And it's not to say that that isn't still a part of an AI-enabled workflow, as you're going to go through in a moment here, but it gives you a lot of automation and a lot of capabilities that you wouldn't have had otherwise because it takes care of some of that background. So can you go over and I know you've got your screen share ready to go. We're going to flip over to your screen share and then talk us through this process real quick.
Yeah, sure. Give me 1 second. Let me share my Claude. And let me also get a threat intel report. So I got a threat intel report for Amos Taylor, and I'm going to ask Claude to find all the atomics for Amos Taylor, and if none exist, give me a list of atomics that I need to create. I'm not going to ask it to create directly. I just want to like look at the list, verify what are the atomics that needs to be created, and then ask Claude to create it. You can also like ask it to create it directly as well. This is yeah, this is much easier for me to like provide human in the loop with Claude desktop. So uh, if atomics exist, give me a list of gowards. So what Claude is going to do is it's going to fetch the Intel report, and it's going to like look for all the atomics using the tool. Yeah, it's going to use query atomics, and it's going to request like for each and every TTP that it found over there, it's going to query whether like atomics exist. So okay, I think in the first iteration, it's just trying to like search whether there are like Amos Taylor exist, and probably in the next iteration, it's going to search by TTPs. So in this case, it's just like searching for multiple TTPs, and it's going to try to find all of those things right now. So it's going to like find all the TTPs, and it's going to like give you a list of things. And you can also like ask it to create atomics from here using some of the other tools that we have. So so based on the threat intel report, it was able to find a couple atomics that already exist, and it's showing what are the atomics that needs to be done. So and once you have this list, you can ask it to do you can ask it to like create, let's say like atomic 2, 3, and 4. And you don't want to do this, like if you don't want to do something, you can like obviously skip it. For example, curling or like doing just a post request to a CTIP, C2IP, you would probably have like IOC indicators and like other stuff over there. So if you just want to like skip some of the basic stuff that a malware would do or like a threat actor would do, you can skip some of those things, and you can just ask it to do only the things that you care about. So you can, for example, you can ask it to do create an atomic for VM sandbox detection via system profiler. So once you ask that, it's going to get the validation schema as I mentioned before. And here you can see like how to like it provides instructions to Claude on how to use each and every one of these fields. like I mentioned before, for elevation required, it's going to say set to true if you are using like sudo or admin privileges. Oh, sorry. Yeah. And for each and every one of those fields, it's just going to provide like description on like how to use that field. So, and once it creates an atomic, it's going to like pass it to the validate atomic tool, and it's going to like show how it can validate a particular atomic and generate a PR ready atomic that you can use.
Yeah, absolutely. So, you're getting something that's syntactically valid, and then it makes it
Mhm.
one less thing that we the humans have to go through to make sure it's correct, and we can kind of go through it, from a semantic and a functionality perspective. Definitely streamlines the process for sure. Now I know we're getting a little close on time here. We're at that time actually. So I just wanted to leave everybody with one other kind of plant a little seed of creativity, if you will, and maybe some food for thought on another option for the use case here. And that's for those who are starting to think about contributing to the Atomic Red Team project. The rule validation is another great workflow, and you can see this here. We're going to provide all of this for you in the recording, and there's also going to be a blog with both these two scenarios as well as a couple other ones you might want to consider. But it's an easy way for you to say, all right, I wrote this detection capability and I want to make sure that it's valid. And it's going to go in here, and you'd kind of given us the idea of it can show you where your gaps are. It can find the edge cases that you're not thinking of as the human, because we're looking at it at a much higher level, and just now give it a chance for now contributing back into the project. And we always make sure that they're human validated. So, fully automated contributions are always going to need extra vetting and validation, but this certainly takes you from idea to 80% solution so quickly, whereas, it might take you 30, 60, 90 minutes to do that in a regular scenario. Getting started, really straightforward. Install it. We saw the information earlier that you provided on the different ways to actually install that depending on your environments. And then just start asking questions. That's part of the beauty of a lot of these is you don't have to know really esoteric, what are the command line flags? What is the syntax? It really makes it a lot more approachable to someone who is new to the environment, new to the tool. And then again, big caveat, if you're in the appropriate lab environment and you have all the authorizations to do so, you can go ahead and start to execute that. Really, really fascinating to see how fast that streamlines processes. And like I said, there are so many other examples of these. There's no way we'd be able to get through them, even if we doubled the time of our SecOps Weekly here. But Hari, thank you so much for not just putting this capability together in the first place, but for taking the time to share it with us and really explain some of the vision behind what you've built. Really hope everybody gets a chance to experiment with that. Lots of other resources are here on the slide. And for everybody who's attending now, you will be getting a follow-up message after the fact. And we're going to put this into a blog in the future as well. So we'll keep an eye on the Red Canary blog, where we'll expand upon some more of these ideas and give you a couple of those other inspirational concepts of how you'd be able to use the MCP in front of the Atomic Red Team program to kickstart your capabilities in the area. Here's the URLs for you to keep an eye on. This has been our, like I said, number 61 here on SecOps Weekly. And coming up next, we have our Intelligence Insights report, where we're going to talk about what we were learning during the month of April. And maybe some of those intelligence insights will be enough really cool threat intelligence that you can use to plug into the Atomic Red Team MCP and build some test approaches for them. So, Hari, thank you again for your time and your contributions. Really always a pleasure to hang out and see what you're up to. Love it. And thank you very much.
Thanks a lot, Phil, for having me here. And thanks, Red Canary, for hosting this.
Yeah, absolutely. Well, thank you everybody for attending too, and have a great rest of your Tuesday. We'll see you next week. Cheers.